Okay, hello everyone. This is another session after OSPF concepts and OSPF configurations, module 1 and 2. And with this one, we're actually going to be doing some configurations and getting a better understanding of how we can configure OSPF on a network version 2. Right. So we have our topology here. Just to go through the topology first before we start our configurations. So you can see we have a couple of routers right here. I have I've divided this topology into two, I don't want to say areas because I want to put them in the same area. We talked of areas already, but I have point-to-point networks. Let me say two networks that I have. I have point-to-point networks. I also have a multi-access network. So if you can see on my left here, this is our point-to-point network we are going to configure. And on my right, we have a multi-access because of this switch right here. Let's label it. Let me see. Let's label it switch 1. Right. So because of that switch, this side, we have a point-to-point network, OSPF network, and this side, let's say we have a multi-access. So we're going to demonstrate configuration of a point-to-point as well as a multi-access. Right. So without routing being configured on this network, it's impossible. Let's say if you have a PC in this, let's call it LAN 1. If you have a PC in LAN 1 and you want to communicate with a PC in LAN, let's say 4 right here, without routing being configured, whether it be static, whether be it dynamic, it's impossible for you to communicate with those two networks, LAN 1 and LAN 4. Why? Because they don't know each other. They don't know if they exist. LAN 1 doesn't know if LAN 4 exists. And how does it know? That's why we have routing protocols. So with OSPF, we went through the whole process of building up the link state database, exchanging packets until every router in the network knows there is another network here, there is another network here. So basically, this is the topology that we're going to be using. And we have a couple of networks, 10110 here, 10114, 192.168.20.0, 10118. These are the networks for our links, the 1011s, networks for our links. You can see from the symbol that we use, those are point-to-point serial connections. We use serial connections. These ones right here. These are serial connections because we wanted to depict a point-to-point, right? We could have used Ethernet links as well, uh, but I just wanted to be more specific, so we use point-to-point, right? On this side, we also have a number of networks, 192.168.60.50.40, and our multi-access being linked by this switch number 1, in the network.70.0.24. So these are the networks that we're going to be using. These are the networks that we're going to be advertising. As far as our router IDs are concerned, okay, starting with the process ID, we're going to be using process ID number 10. These are just instances in our routing protocols. Here we have one instance process ID number 10, area 0, because we are not dealing with multi-areas yet. In this course, CCNA 3, we only deal with single area OSPF. So we have our area 0, which will be our backbone. And for our router IDs, router 1, 1111, router 2, 222, router 3, 333, 4455. So those are the router IDs that we're going to be using for each of our routers. So we have router 1 here. Let me see. This is router 1, router 2. So this is supposed to be router 3. This can become our router 4, our router 5. and our router 6. Right. Now getting on to the configurations. Our packet tracer on, all right, let me see. Right. So I think in the past sessions that we're having, I put much emphasis on building your own network, starting your own network from scratch. Instead of using networks that are on packet tracer, at this stage, CCNA3, you should be able to build networks from scratch on your own. You put configurations from scratch on your own and see if your network functions. So our topology, we have it. Now let's build our network. So I'm going to be using this 1941 router, right? First thing, I'm going to look at the interfaces that we have here. So if I look at, right, this is the view, the physical view of the device. I can see I have the aux, I can see I have the console, and I have 2 Giga Ethernet. Let me just say Giga Ethernet. Let me confirm. But I think those are Giga Ethernet interfaces. Enable, let's say short. Right. So our 1941 router, it only has, without modules added, it only has 2 Giga Ethernet interfaces, 00 and 01. But with the topology we are using, I think you can recognize we have serial links there. So where do those serial links come from? With this router, we have modules that we can add, sort of extensions. So we can add, this is how we add, all right, just a minute. And this is how we are going to add some extensions on our router here. We go to the physical, all right, we go to the physical, all right. The extension we are going to add here is our serial links. Let me see. This Ethernet switch, right? You can see from this description, we have our 2-port serial high-speed wide area network interface card, providing 2 serial ports. So we are going to add this module to our router so that we can have the serial ports. Expansion modules, we call those expansion modules, right? So if I go here and check my interfaces again, okay, I switch this on. Okay, the router is switching on. If I go and check my interfaces again, you will see I'll probably have added 2 more serial interfaces. Right, meanwhile, let me do this. Okay, no, enable short. Right, voila. There I have added 2 serial interfaces, these 2. So according to our topology, these are going to be very useful in demonstrating our point-to-point OSPF network. Right, so I have this one, let's have 3. Right, let's have 3, just copies of those. Now let's have our serial link. No, I don't want this one. Terminal, no. We use this one. Let's not have our serial link connected to this. We connected to this. And this one connected to this one. Right. This is the first part of our topology. Let me go back and see. That's the first part of our topology. Then we can have, let's put PCs on LAN 1, LAN 2, LAN 3. Let's just put PCs here so that when we want to demonstrate if we have connectivity, we can use that. So let's put a PC here. Let's put a PC here just to demonstrate our LANs. connectivity. All right. So I'm going to connect this to the Giga Ethernet. And let's connect to 00. Let's connect all of them to 00. All of them to 00. All right. This is the first part of our network. So I'm going to, I think, let me just separate these two for now. Let me deal with the point-to-point first. So I'm going to pretend this link is not there. We are going to join them. It's not there. And now let's deal with our point-to-point network first and see how we are going to configure OSPF on that network. All right, so this is our network. Right. Going to our configurations, I'm going to be using this set of steps right here. If I'm configuring a point-to-point network, or if I'm configuring any OSPF network for that matter, these are the steps that I'm going to take. Number one, you need to configure the process ID, which gives the instance of the OSPF. From there, you configure the router IDs, which are the unique identifiers of the routers in a given OSPF network. From there, you configure the interfaces that participate in OSPF routing process. Basically, what you're doing is advertising. You configure the networks that you want to advertise. That's step number 3. And you can see we have 2 ways of doing that. One, you configure directly on the OSPF network, or 2, you use the network command. I'm going to demonstrate using both those ways. Number 4, we configure the passive interfaces. There are some interfaces where we don't want routing messages to be sent. For example, on our network, we don't want routing information to be sent to this PC, because this PC does not need routing information. So what do? We configure the interface linked to this PC or this LAN as a passive interface so that it does not receive those routing messages. So basically, those are the steps that we're going to take in our configurations. All right, step number 1, configure the process ID. So this is the command we're going to use, router OSPF, then our process ID. Let's go to every router in the network. Okay, let's go to CLI enable, configurations, router OSPF. Right, our process ID, let me check. Right, our process ID is 10. 10 cannot start, they must list the one app interface. Okay, we have not configured the interfaces yet. Our networks, let me just go through that quickly. That's the good thing of starting from scratch. You learn quite a number of things. Right, let me configure my networks on this one before I go to the router OSPF configurations. Right, interface. Let's start with this interface. I'm gonna put this one on top. All right, let me start with this interface. This is Gig Ethernet 0, 0. Gig Ethernet 0, 0. Interface, Gig Ethernet 0, 0. Right. IP address. According to our topology, the IP address is 192.168.10.1. 192.168.10.1. 255, 255, 250. Right, no shot. That interface is up. Let's go to the serial ones. This one, serial 011. Right, interface, serial 011. IP address. The IP address, I think is 10 let me just double check, 10.119. 10.119. It's slash 30. It's 255, 255, 255, 252. No shot. Okay, we're activating all our links. All right. We have this link as well right here. This is serial 010. Serial 010. Serial 010. All right. IP address is 10. Let me double check and confirm. It's 10.112 slash 30. 10.112 slash 30. All right, this is good. No shot. All right, let me just confirm. Show commands. So I'm going to first brief. Just to confirm all my interfaces are up with the correct addresses. So this one is proper. Router number, okay, this should be router number 1. Let's just say R1. Let's put R1. That's our router 1. Right, going to our router 2. Let's configure our router 2. And we start with the LAN interface, gig 00. Big interface, gig 00. IP address 192.168. It should be 20.1. That's our default gateway. 55.255.255.0. Let me share it. Interface up. Then we go to the serial. Interface serial. If you can notice, we activated one side of the serial, but it's still showing red. Why? With the Giga Ethernet interface, we just activated the interface and voila, it went green. Why is the serial interface link still red? Right, interface serial. Okay, this is our router. Let's start with this one 010. Okay, 010. You put our IP address. Give us a IP address. What's the IP address for that link? It's this one, .1, 10.111. Okay, it's 10.111. 55.255.255.252. Activate that link. And as soon as we activate that link, I think it should go green. So the point-to-point, both sides of the link needs to be up so that we can be able to send information on that link. Right, let's activate this one, 011. 011. What's our IP address for that one? Go back to the topology, it's .5, 10.115. Right, go back 10.115. That's our IP address for that. Okay, no shot. This one is proper. We are done. Show IP interface brief, just to check if all the configurations for the interfaces are correct, and voila, they are correct. We have them up. All right, this one is done. Let's go to the last router, router number 3. All right, router number 3, this one stays on top. Okay. All right, let's start with our line, 600. This one should be easy. Interface gig 00. Okay. The address That is router number 3. So it's 192.168.30.1. And that's our default gateway. Default gateway for PCs in that LAN local area network, right? No shut. This one good. Let's go to the serial links. Start with this one. 010 interface. Let's interface serial 010 IP address. Right. Going back to our topology, our IP address is .10. So it's 10.1.1.10. 10.1.1.10. Start proper. Yes. 255, 255, 255, 252. Shut. Right. One last link is .6. Okay. Let me just go back. This link 011. So it's serial 011. IP address .6. Just to be sure. Yes. It's .6. It's .6. We activate the link. All right, all our links are activated. Our point-to-point network is now proper. All right, let's just configure IP addresses for our PCs. We would like to test for connectivity before we start so that we can see if we have connectivity. So this network is 192.168. That's router number 2, so it's 20. Let's have just 10. All right, our default gateway is 192.168.20.1. All right, that's for PC on router 2. On router 1, let's have our IP addresses 192.168.10.10. Those are the IP addresses of our PC. Our default gateway is 168.10.1. That's the IP address of the interface gig 00. Right. Last PC to configure IP. Right. That's router number 3. 192.168.30.10. Same here. 192.168.30.1. Done. Right. So our network, as far as IP addresses are concerned, or configured. Let's test for connectivity. Without any protocols, without any static IP route configurations done, are we able to have connectivity? The answer is definitely a no, but let's check. Let's check. Let this be our PC1. Okay, I cannot have PC1 twice. Let this be our PC3. In LAN 3, our PC2, and this becomes our PC1. Right. So we are going to check connectivity between PC1 and PC2. We know there is no connectivity because there are no routing protocols configured. But let's just check 192.168.20.10. Destination host unreachable. Why? Because we don't have routes configured on our network. All right, so we're going to, at the end of configuring our OSPF, we're going to come back to this ping command and test for connectivity. All right, but before we get there, we start our configurations. OSPF now. All right, so the first configuration we are going to start with is the process ID. On all the routers, process ID, router OSPF instances. All right, router OSPF 10. That's our process ID. And you can see our mode changes from the global to the router configuration mode. From the router configuration mode, that's where we can do almost everything else. We can advertise the networks. We can configure the passive interfaces. We can configure the router IDs from that mode, right? So number two, let's go to the router IDs. This is router number one, and its router ID is 111. The command for router ID is just router ID. So we have router ID 1111. Right, a little bit more info on the router ID. Unique identifier of a router in an OSPF network. If not configured, if a router ID is not configured, what happens? We can use the loopback interface, the highest IP address loopback interface, the highest, we can use that one as the ID. If not configured, we can use the highest interface, the IP address of the highest interface on the router as the router ID. But it's always safe to manually configure the router ID so that you can control, for example, the election of the designated routers, the backup designated routers. It's very important you manually configure so that you have control of which router becomes your DR and your BDR. Right, so this is our router IDs 111. I'm going to go through all the routers and do that process first. Right, for this one, our process ID, router OSPF10 with our router ID. This is 2222. This is router number 2, done. And we go to router number 3. Let me do this. And we go to router number 3, same process. Router OSPF10, router ID, this is supposed to be 3333. Right, done. After router IDs are done, what's the next step? Our next step, configure the interfaces that participate in the OSPF routing process. Right, the next step is now advertising the networks. Now, in OSPF, we configure the router to advertise the interfaces which a router is directly connected to. So if I'm looking at this interface, let me go back to my topology. If I'm looking at this interface on R1, what is R1 going to advertise? R1 is going to advertise this network right here, right? 10 minutes. R1 is going to advertise this network, right? How do I put this? So it's going to advertise this one, it's going to advertise this one, and lastly, this local area network. Because those are the three networks R1 knows. So it's going to advertise those. R2 is going to do the same, advertise its directly connected networks. R3 the same. And after all the packets have been exchanged and the databases have been built, then every router knows every other network in the network. So basically, that is how OSPF is configured. Very simple. Very simple. Let's go to the configurations. Voila. All right, starting with R1. Which networks does R1 know? Our command is network address. This is our command right here. Network address, wildcard mask, area ID at the end. So for this network, let's find our wildcard mask. What is our wildcard mask? For this network, this one is the only one going to be a bit tricky. So let's look at network 10 with /30. /30, what will be our wildcard mask? So with /30, you see that you get the wildcard mask from subtracting 255.255.255.255. This is a /32 minus /30. /30 is 255 dot 255 dot 255 dot 252. So if I subtract, I get a 0 here, dot 0 here, dot 0 here, dot 3. That's how I get my wildcard mask. So for slash 24, it's 0, 0, 0, 255. Very easy to get your wildcard mask. If you go back to the previous videos we did, I think we went through how to calculate the wildcard mask. So we're going to use this one for slash 30, this one for slash 24. Right, so we're going to advertise these three networks, this one, and lastly this LAN on our router number 1. Let's go. Right, the command network address. Let's start with that command. Our network address, we have 10.1.1.8 slash 30. That's the first network we're going to. Let me confirm. Yes, slash 30. Slash 30. My wildcard mask, it says 000.3. From there, area, my area is area 0. Anything else, done. Right. That first one is done. Area 0, we are now advertising this one. Right. Second network, we are going to advertise 10.1.1.0. The same area. So I can do this. Okay, let's advertise .4 here. Just to confirm, no, it's .0. It's .0 here, not .4. .0. That's our second network. We are going to advertise from R1. Then lastly, we're going to advertise this one, which is our LAN interface. Okay, it's 192.168.10. Okay. Right, it becomes 255 here. Because it's a slash 24. I move this. I move 192.168.10.0. Right. Those are our three networks advertised. Voila, and done. So this is the first way. How many minutes do I have? 5 minutes. This is the first way to advertise your networks using the network command. Right? I want you to notice another way we can do this. Yeah, every time I receive a call, I think my network goes down. Let's continue though. Right? I want you to take note of this. 2 ways we can advertise our networks. I think this is very important. Right. So if we want to advertise the network 10.1.18/30, that's the network you want to advertise. We can use the network command in 2 ways. We advertise the network. Here we have the network 0003. We use the wildcard mask to advertise the network. Number 2, we can advertise using the interface. So using the same command network, we advertise the interface instead. When we advertise the interface, the router knows which network the interface belongs to. Therefore, if you advertise the interface, you directly advertise the network itself. So it's easier though to advertise the interface. Why? Because you don't have to calculate the wildcard mask. You use the quad 0 command. So your wildcard mask becomes 000 if you advertise the interface. And what is the interface in our network? So if I go back to my network and I want to advertise this, interface. If I advertise this interface, therefore I advertise that network. The interface is .9. So I can come here and say 10.1.1.9 with my quad 0, area 0, area 0. These 2 commands do the same thing. The only difference, this one is easy, I think. You don't have to calculate the wildcard mask. So you just use a quad 0. What is the interface IP address? You use the interface IP address with quad 0. If you don't want to do that, you identify the network, then you use the wildcard mask to advertise the network itself. So two ways of using the network command there. So let me see. With the router, we just configured. Let me see if I can have my show. How many minutes do I have? 2 minutes. Let's have a show run just to see our configurations, the configurations that we've done so far. Right. So I can see right here, router OSPF10, my router ID is there, and the networks that I have advertised are there. We use the network command, let's say with the first, according to this, we use this way of advertising our networks, this way. We use this one. So with R2, we're going to try and use this one and see if we have the same results. Right, let's go. Let's go to R2. Actually, there are quite a number of ways of advertising your networks in OSPF. The other one is going to directly on the interface and configure the OSPF process and all the configurations necessary to advertise the interface. Right here, so this is now router number 2. So what are the networks we want to advertise? With router number 2, we have 10.110, 10.114, and 192.168.20. Right, let's go. Network. Let's start with the LAN first, 192.168. What is the interface IP address? .20.1. That is the interface IP address. This interface here. This one, .1. All right. So I have .1, 255.0. We are using the other method, area 0. We'll see if it works. Right. So I can see I have less than 1 minute. Let me stop here. We continue from R to up until we finish.